Hello everyone. Get ready to revolutionize the way we maintain solar energy systems. Let's dive into PV Guardian, your smart solution for solar panel inspection. The global PV industry is growing at a rapid pace. As early as 2023, global installed PV capacity accounted for 73% of global installed renewable energy capacity, reaching 345.5 GW. Throughout the lifespan of a photovoltaic system, challenges such as component wear, hot spots, potential induced degradation, micro cracks, and electrical wiring issues are prevalent. Surprisingly, even minor obstructions like leaks can significantly affect performance. That's why regular, meticulous inspections are essential for maintaining the efficiency and the longevity of your PV systems. Currently, the industry standard methods for inspecting photovoltaic systems fall into three categories: embedded performance monitoring, conventional visual inspection, and cell level analysis. However, each of these methods has its own challenges: challenging operational data collection, inefficient manual inspection, and limited data analysis and processing capabilities. These issues may negatively impact the PV generation efficiency and economic benefits of PV plant. To tackle the challenges of photovoltaic system maintenance, we proudly present the Photovoltaic Doctor system. It encompasses drone-based automatic inspection technology for swift and thorough assessments, intelligent defect detection algorithms that pinpoint issues with precision, three-dimensional management systems for comprehensive oversight. These cutting-edge components deliver a streamlined, precious, and economical approach to photovoltaic inspections. The system combines front-end visualization and reporting with back-end draw management and deep learning for PV plant inspection. The front end displays module states and generates fault reports, while the back-end manages flight paths, stores data, and uses deep learning network for automated fault detection to ensure efficient and accurate maintenance. In this video presentation, we will witness a combination of real-world 3D visualizations and operational interface demonstrations. This slide showcases our autonomous UAV inspection path planning project, enabling UAVs to autonomously handle tasks like takeoff, landing, and charging for inspections with minimal intervention around the clock. Here, it comes the UAV multi-sensor system for PV panel inspection. The UAV gathers data such as visible light, thermal imaging, and meteorology, labeled with defects like cracks and debris. This forms a multimodal dataset to train the deformer model, improving defect detection and power estimation. The model is applied to PV plant O&M for diagnosis, power estimation, and broadcasting, ensuring efficient system management. Using deep learning and a thermal infrared fault image database, we achieve intelligent defect recognition for PV panels. Thermal images highlight defects alongside healthy panels. This technology enhances defect detection accuracy and efficiency, enabling timely maintenance and optimizing PV system performance. We've integrated inspection analysis into a PV data management platform. The current interface with hotspot flatting quickly identifies fault modules, while the historical interface allows long-term comparisons, improving monitoring efficiency and supporting maintenance decisions. Our system enhances inspection efficiency in large-scale PV plants and improves diagnostic accuracy with remote monitoring in distributed systems. Focusing on the circular economy, we've also developed PV panel recycling and material reuse processes, promoting sustainability. With widespread adoption, we believe this system will boost efficiency, accuracy, and sustainability, driving the PV industry toward a greener future.